In this video series, we'll learn about the Cartesian Coordinate System. You already know that the surface of the wall in your room or the surface of your textbook are examples of planes. Even the surface of this digital board is a plane. Now we take some point P on this plane. To determine the exact location of P, or any point on this plane for that matter, we use a pair of numbers x, y called coordinates that are nothing but signed distances of the point from two mutually perpendicular reference lines called the x-axis and the y-axis. The point of intersection of these two axes is called the origin and is denoted by the letter O. Both the coordinate axes are calibrated according to the scale we choose. In the coordinates x, y of a point, x is called the x-coordinate or abscissa of the point and is equal to the signed distance of the point from the y-axis. It is always written first while writing the coordinates of any point. Y is called the y-coordinate or simply ordinate of the point and is equal to the signed distance of the point from the x-axis. It is always written second while writing the coordinates of any point. Therefore, coordinates of origin O are 0, 0. All distances measured horizontally to the right of the origin are positive, and all distances measured horizontally to the left of origin are negative. So OX is the positive x-axis and OX dash is the negative x-axis. Similarly, all distances measured vertically above the origin are positive and all distances measured vertically below the origin are negative. So OY is the positive y-axis and OY dash is the negative y-axis. If you need the coordinates of a point, say Q, what you need to do is drop a perpendicular each from Q to the x and y axis. Then this will be the x coordinate, which will be the same as this distance, and this will be the y coordinate, which will be the same as this distance. The coordinate axis x dash OX and y dash OY divide the plane into four quadrants. This is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. Clearly, any point that lies in the first quadrant will have both the coordinates positive. Any point in the second quadrant will have negative x coordinate and positive y coordinate. Any point in the third quadrant will have both the coordinates negative. And any point in the fourth quadrant will have positive x coordinate and negative y coordinate. Now let us solve some examples to make things clearer. Example 1. Find the coordinates of the point R in the given figure. To find the coordinates of R, we need to drop a perpendicular each from R to the coordinate axis and calculate the signed distances from the axis. So x coordinate of R will be this distance, which is equal to this distance, which is equal to -2. And y coordinate of R will be this distance, which is equal to this distance, which is equal to 4. So the coordinates of R are -2, 4. Example 2. Plot the point S -1, -3. To plot S, we need to do the reverse of what we did in the previous example. Now the x coordinate of S is -1 and the y coordinate of S is -3. Make a line perpendicular to the x-axis at x equal to -1 and a line perpendicular to the y-axis at y equal to -3. Their point of intersection gives the required point S. Example 3. In which quadrant do the following points lie? A -4, -6, B 3, -4, C 2, 0. A. Since both the coordinates of the point are negative, the point lies in the third quadrant. B. Since the x coordinate of the point is positive and the y coordinate of the point is negative, the point lies in the fourth quadrant. C. Though the x coordinate here is positive, if you notice the y coordinate of the given point is 0, which means it is neither positive nor negative. Let us plot this point to see where it lies. The x coordinate is 2, so we draw a line perpendicular to x-axis at x equal to 2. The y coordinate is 0, so we draw a line perpendicular to y-axis at y equal to 0, which is the same line as the x-axis. The point of intersection of these two lines is our point 2, 0, which we wanted to plot. Therefore, we say that this point lies on the positive side of x-axis. In fact, it lies on the boundary of first and fourth quadrants. The point 2, 0 gives us an important information about any point that has its y coordinate as 0. Any point that has its y coordinate as 0 lies on the x-axis. You can take any example, plot the point and see it for yourself. Similarly, any point that has its x coordinate as 0 will lie on the y-axis. Example 4. Where does a point having y coordinate 1 lie? Let such a point have coordinates x, 1. All the points that have their y coordinate 1 will lie on this line, which is perpendicular to the y-axis at y equal to 1. Alternatively, we can also say that all the points that have their y coordinate as 1 will lie on a line parallel to x-axis at y equal to 1. Example 5. If the three vertices of a rectangle are 0, 0, 2, 0 and 0, 3, find the coordinates of the fourth vertex. Let O be the point 0, 0, A be the point 2, 0, B be the point 0, 3 and C be the point xy. Now point C is the fourth vertex of the rectangle whose coordinates we want to find. Let's plot O, A and B. Clearly O is the origin, so it is this point. Coming to the point A, its x coordinate is 2 while its y coordinate is 0. So A will be this point. Coming to the point B, its x coordinate is 0 and y coordinate is 3. So B will be this point. Let us complete the rectangle now. Since we know the three vertices of the rectangle already, we can easily complete the rectangle knowing that opposite sides of a rectangle are parallel and equal and that the adjacent sides of a rectangle are mutually perpendicular. So this is the point C whose coordinates we want to find. We already know that the x coordinate of a point is its distance from the y-axis and the y coordinate of a point is its distance from the x-axis. Therefore, the x coordinate of C will be this distance, which will be equal to this distance, which is equal to 2. Note that the point A has the same x coordinate. Similarly, the y coordinate of C will be this distance, which is equal to this distance, which is equal to 3. Again note that the point B has the same y coordinate. So the coordinates of the point C are 2, 3. In the next video, we'll learn about the distance formula used to find the distance between two points whose coordinates are known.
If you like what you saw, don't forget to hit the subscribe button. This is Abbyshek Chandra signing off. Take care.